We're going to look at more related rate problems involving right triangles. Today we're going to look at things that involve like cars or people moving away or towards something. So car A is traveling west at 50 miles per hour and car B is traveling north at 60 miles per hour. Both are headed for the intersection of two roads. At what rate are the cars approaching each other when car A is 0.3 miles and car B is 0.4 miles from the intersection? Okay, so this one, they're both headed towards the same intersection. Okay, so I'm just going to put a little star right here. This will represent my intersection. So car A is going west. Okay, well, west would be to the left. So car A is approaching the intersection from this direction. So I'm going to call that A for car A. Car B is traveling north. So car B is approaching the intersection from this direction. And this right here will represent the distance between them. Okay, so nothing gets a number in it, okay, because this side length is changing, this side length is changing, and this distance will also be changing. As they get closer together, this distance will be getting shorter and shorter. Okay, so no numbers in the picture. If you look, the two numbers they give us, they come after the word when. So that means they do not go in the picture. So from here, I'm going to write my equation. So that'll be a squared plus b squared equals d squared. So my derivative will be 2a dA dt plus 2b dB dt equals 2d dd dt. And if you use different variables than me, that's fine. I just use A to represent car A, B for car B, and then I just use D for the distance between them. Okay. Then I've got A, B, C. So these are my lengths. Okay. So they said car A is 0.3 miles. Car B is 0.4. I don't know what C is yet. Okay. Then the DTs, these are my rates. So car A is going west at 50 miles per hour. So make sure with your rates, you always need to determine whether they're positive or negative. Okay, so both cars are approaching this intersection. So the closer A gets to it, the smaller this distance gets. So that's going to make my rate negative on this one. Same thing for B. The closer B gets, the shorter this distance gets. So B is also going to be a negative rate because that distance to the intersection is getting smaller. Okay. And it says, at what rate are the cars approaching each other? Okay, so a rate means we're looking for one of our DTs. So dt is the only one left. Okay, and that's this distance right here, okay, between the two cars. That shows how they're approaching each other. Okay, so that means I need to find C. So I'm going to go back to this equation. So that will be a squared, so 0.3 squared, which will be 0.09. Plus b squared, so 0.4 squared will be 0.16. That's going to equal d squared. So that'll be 0.25 equals d squared. Sorry, I don't know why I put a c here. And that'll make my d 0.5 miles. Now I can take all of this, plug it into the derivative, solve for dd dt. So I'm going to have 2 times 0.3 times negative 50 plus 2 times 0.4 times negative 60 equals 2 times 0.5 dd dt. So I'm just going to add this up. So multiply those, add them together. That gives you negative 78. 2 times 0.5 is 1. So you get negative 78 for your dt. And then I just need my unit, and these rates are in miles per hour. So dt is going to be 78 miles per hour. So let's look at this next one. Two cars start moving from the same point. Okay, so now they're leaving from the same location. One travels south, so one is going to be going down. The other is going to be going west. Okay, so here's where they're leaving from. Here's like my intersection. One travels south. Okay, so I'm just going to call this S so I can remember it's the car that's going south. You can call it A, you can call it whatever you want. Okay. The other one is going west, so I'm going to call that W. At what rate is the distance between the cars? So this represents the distance between the cars. At what rate is the distance between the cars increasing 2 hours later? So my equation here will be S squared plus W squared equals D squared. My derivative will be 2S ds dt plus 2W dw dt equals 2D dd dt. So we've got S, W, D. Okay, so these are our links. And then the ds, the dw, and the dd dt's, these are our rates. Okay. So the one going south, so that would be the ds dt, is 60 miles per hour. So the further this travels, the longer this side is going to get. So that's going to make this rate positive 60 miles per hour. Then the one going west, so again, this side length is getting bigger, so that will also be positive. Okay. At what rate, so they're asking for a rate, so that means a dt. Well, dt is the only one left, which is what they're asking for, the distance between them, so the rate for this side. So now I need my S, my W, and my D. So they didn't give us any links in this one. Okay. But since we know the rates and we know the time, we can use our distance equals rate times time. So to find S, that car is traveling at 60 miles per hour for 2 hours. So that's going to make S 120. Then W, that car is traveling 25 miles per hour. So 25 miles per hour times 2 hours is going to make W 50 miles. Then to find D, I don't have a rate for D, but I still have the equation. So I can do 120 squared plus 50 squared equals D squared. So that'll make D 130 miles. Then I can just go back to my derivative, plug everything in. So I'm going to multiply, add those together. So 2 times 120 times 60 plus 2 times 50 times 25 is going to give me 16,900 equals 260 dd dt. Then I'm just going to divide, and that'll give me dd dt equals 65 miles per hour.